watching. Hope you guys are having a spectacular, rad day. Welcome to the 4 program. In this video, we're going to be going over Unit 3, Air Resistance. This is the beginning of this unit. In this unit, we'll be talking about air resistance and the science behind air resistance. Really, what is it in general? To those watching, to the Kenyans watching, our CAD operations team is working on creating 3 prototype designs for you guys to be sent. So we'll let you guys know about that. Stay tuned for more updates regarding that. And to those watching and all those watching, yes, you guys have saw me. I decided to participate in the breakthrough challenge. Hopefully that video goes out there and hopefully it resembles some meaning at least. But we're not going to give up on our mission. We're going to keep going as moving forward. And hope everyone's 3 weeks of school, the beginning of school, has been going well as well. So let's talk about first today, what is air resistance? What is the word resist? What is that? What is this word? It's air and resistance, right? I'm not going to do another pen, pineapple, apple pen. We should put that song sometime. So anyways, what is air resistance? The definition is that it's a force acting on an object that's moving through air flowing in the opposite direction. In general, it means that an object's force is colliding with the airflow, which is the other force, and basically the object's force is colliding with the opposite force, which is the air molecules, and they are basically colliding. What does the word resist come from, though? What does that word resist from air resistance? What does that prefix of that word come from? Resist means the object's movement is slowed down by friction as objects collide with air molecules, which makes sense because when an object's movement is essentially colliding with air molecules, the forces are going to collide, and with the forces collide, both of them are going to slow down. They're going to be slowed down due to friction. It's going to slow down both objects' movements on both angles. One object's movement versus the air molecules that are colliding on the opposite direction. Some good examples for this are paper airplanes. Paper is colliding with air molecules. Riding a cycle is also colliding with air molecules as well. You're colliding with the wind, the breeze as you're speeding. Also parachutes. The material of the parachutes are also colliding with the air molecules as well. I'm going to give you guys a good video to take a look at. This video is from the advisory science. This video goes really good in depth about really what is
air resistance is a type of friction that tries to slow down objects as they move through the air. Some everyday examples of air resistance are feeling a breeze when riding a bike, or wind blowing through your hair and clothes while you're walking. When air resistance is high, objects slow down quite a lot. Some examples are the force of wind on an umbrella, making it hard to move against the wind, or parachutes, which are actually designed to have high air resistance. This helps them to fall slowly and land safely. Or bulky, wide-load trucks, which can slow down quite a lot due to strong winds on the highway or motorway. All of these objects have a large surface area. Their bigger surface means more space for air to push against. So this creates more air resistance and slows down these objects quite a bit. We can reduce air resistance by using objects with slim, pointy, torpedo-shaped structures. This shape is seen in nature when birds tucking their wings to dive faster through the air, or when engineers make high-speed trains that can cut through air easily. Aerodynamic sports cars and bicycles also have this torpedo shape, and this makes it harder for air resistance to slow things down. Why not check out the free resources for this and other lessons, or inquire about the full curriculum. Link in bio.
Yep, so this video is really spectacular. You guys should definitely step to them. Shout out to Advisory Science. They really go over in depth the explanations behind certain science materials, such as friction. They also go over forces, simple machines, water resistance, etc. Excuse me. my throat's very stuffy. But anyways, they go over a lot of good things like levers, a lot of good fun materials, and they go over like a lot of good fun science topics. They're really good at this. So shout out to Advisory Science for doing so. And they go over this with a lot of examples. This is very awesome. I hope that 2-minute video was able to give you guys some idea of really what really is air resistance. Let's take a look at some diagrams. These diagrams are for air resistance specifically. These are two common ones. The common one is when a person comes out of an airplane from and basically do a parachute. So when a person goes down, and air resistance is basically going up, the air resistance is colliding with the person's body, the body's weight, and Fg is going down. Air resistance is the normal force, and we're seeing that once the air resistance collides on the person's body, gravity is allowing the person to go downwards, essentially going downwards, vertically downwards. So that's really, really awesome. You can see that in this example. Let's talk about the science behind air resistance. Really, where does it come from? The science behind air resistance, as we've talked about, this is a good summary, is that the air molecules collide with the object's surface, creating a force that slows it down, which makes sense because friction is allowing the air molecules, it allows the force to slow down when an object and air molecules collide. In other words, form of friction is caused by air collisions. Some factors that we can also discuss regarding with air resistance are object speed, shape, air density, cross-sectional area. Those are really, really good topics to discuss. When we talk about air resistance, we talk about a lot about aerodynamics in these circumstances, so that's really, really awesome to kind of understand. We can see here how the object's behavior, when an object is behaved under air resistance circumstances. We can see here that the pressure is over here. The pressure is, you can see how friction is behaving. We can see that certain objects, if they're big, pressures instilled. We can see it as well over here. There's a flow of separation, high kinetic energy, low pressures, and a lot of pressures that are behaved on three different types of objects over here as well. We can see a backward pushing force in this object, and a pressure recovery with an attached flow giving a forward pushing force as well. A lot of different types of behaviors that can happen with the objects. There are many different types of objects, and depending on the material, the speed, shape, density, and the cross-sectional area, that will give you an idea of really how are the air molecules essentially behaving. So that's really, really cool to understand. Now let's discuss about in planes specifically. Well, you may be wondering, planes as well also have this as well. The science behind that is that it's essentially known as drag, and that's caused by the friction between the plane's surface and the air molecules and air pressure. To overcome the air resistance, you may ask? Essentially to overcome this air resistance, the thrust from, because since air resistance in planes, if you have a lot of air resistance and you don't have something to power up these planes could essentially slow down. They're not going to take off. To make sure they take off, the thrust from the engineers can help slow the plane to stay with speed and altitude, especially when you're going on high altitudes. The thrust will allow the plane to move forward, and if they don't have those engines, those thrusts, then unfortunately the plane will go into something that's called a stall, which is something that we don't want to happen in many circumstances as well. So we can see here a good example. We can see here that the lift is a normal force, the weight is the F of G, thrust is essentially pushing the plane forward, and we're seeing drag, which is the air resistance that's pushing it, slowing it down as well. Drag is a mechanical force that's generated by the solid object moving through a fluid. These fluids are essentially coming from the air specifically as well. A special video, we'll be talking about Bernoulli's Principle as well when we're talking about air resistance. There's a special video that's going to be coming out soon, so stay tuned on that. A special video is going to be coming out soon regarding with Bernoulli's Principle, so stay tuned on that. We'll discuss that as well. Now let's talk about the types of drags. The types of drags in planes specifically. So for the types of drags, there are three different types of drags when we talk about in planes specifically. There's one profile drag that is essentially it's essentially caused by the friction of air moving over a surface of the aircraft and by the shape of the aircraft. We also have induced drag, where the wings create this wing-tipped vortices that essentially creates a drag. The consequences of that is that the lift is being generated as a result if it's induced, and we also have a parasitic drag that's caused by any part of the aircraft that is not contributing to lift. When we talk about these three different types of drags, know that we're talking about either friction in general. When you're talking about these three different concepts, know that we're talking about three specific things. We're talking about friction, we're talking about the lift, and we're also talking about the wings. A lot of these wings also, and airfoil. A lot of these terminologies with drag comes with airfoil. So we can see some good examples over here. This is one of them where essentially the turbulence and drag is slowing the airflow as well. We can see here. Leave a comment down below what you guys think these two types of drags are. Is it a profile, induced, or parasitic drag given this? I know this is a bit complicated, but our team is trying our best to we're trying to, and I'm also trying my best to simplify these definitions as much as possible, just to give you guys a good understanding of what drags are in general and other concepts as well. So we're going to show you guys some diagrams as well. Leave a comment down below what you guys think these two types of drags are. In terms of this projectile motion, we'll talk about two specific simulators on GeoGebra. This is on projectile motion, how projectile motion is essentially shown in air resistance. So this is a good projectile motion with air resistance. Shout out to William C. Evans. He talks about how projectile motion behaves under drag specific circumstances. We can see here that we can change the K value, the V scale, which are the vector arrows, the V initial, and we can see here that the theta angle, which is essentially, this is the projectile motion right here. We've gone over this. Let's take a look at those two videos if you guys would like, but the projectile motion, we'll go over this really quickly. It starts from this point and then it goes essentially back down here because of gravity and, you know, the formulas that are associated with that as well. We have the G value. The G value would essentially minimize or zoom in the graph. We have the Y initial, which is the initial projectile motion, I would believe, and we also have the T scale, the time that's essentially shown. We have R drag and R vec, and we have the ellipse that's also being shown. The ellipse that's being shown is the airfoil, I believe. So we can see here as time goes on, this is right now at 64 degrees. We can see that if we toggle with any of these parameters, certain things would essentially change. This is what it would look like as a typical airfoil, 61 degrees, and we can see these are the parameters that are associated with that, which is very, very cool. So now let's take a look at one more. The ellipse, just keep in mind this is the ellipse, this is the airfoil, and this is the projectile motion that's essentially connected with this, with certain vector directions that are applied in air resistance. This is another projectile GeoGebra simulator as well. Shout out to Judah L. Swartz, who created this for us as well. Created this for all of us as well to understand. We can see here that, so this is, I would believe, how the V initial is essentially how air resistance affects the velocity of certain objects. So let's take a look at this. So we can see here dv, dt, these are dt, dv, these are all, I believe, derivatives. This is derivatives. I think this is for physics C students, or like those who are doing advanced physics, I would say. But we're gonna go over derivatives later on. We're not gonna go over these kind of things. These are a bit confusing. But we have, you know, these certain things. We can see here that the velocity and the height are being shown. Let's see what happens if the air resistance is off. So if we start doing that, let's see if I can play it. We can see here that the V initial and the height are essentially, the V initial will go down and the height is going to go up as time goes on. Let's see what happens if we put the air resistance as low. If we put the air resistance as low, notice that the velocity is going a little bit more narrow. It's going closer to the graph, and we can see that the height is decreasing as well. So we can see that that's happening, which is, yes, it's curving down a lot more early onwards, you can see. And now let's take a look at the height. If it goes extremely high, let's see what happens. If it goes extremely high, notice that there's a lot of dots that are being shown in the V initial because the initial velocity is affected. It's slowing down a lot more, meaning it's slowing abruptly when air resistance is essentially high. And we can see that the height, it goes really slow. So the relationship with this diagram specifically is that as air resistance goes over time, the V initial would go down. Oh, stop animation. Stop animation. I'll stop it right there. Okay. So we can see here that with all these things coming up to play, we can see that as the air resistance is higher, the initial velocity would decrease, and as a result, the initial height and the height in general of certain objects would decrease because friction is taking a big play at this. So I hope these two simulators were helpful as well to discuss. Now, this is the ending for this video. I'm going to talk about some really good updates as well. If you guys have any quick questions with biking, please feel free to email us, and please also contact us as well. You guys can, when sending questions, related or off related, you guys can write the question, send a picture, and we'll respond when we have the chance of anything. And to those watching, I want to give a big appreciation to the CAD team. The CAD team is doing their real best. Without them, we would not be able to get any of these designs going. I want to give them a huge shout out right now, and I hope, to those watching, I hope this video was fun, this video was educational, and yeah. So I don't have a joke ready with me, but let me see if I have a joke. Maybe I can search up in Google because I sometimes come in jokes, but not all the time. Let's see here. Let's see. Fun jokes. Let's see. Funny jokes. Let's see here. Okay. Let's see here. Okay. This one's a bit. You know what? Let's do this one. What did the buffalo say when his son left? Bye, son. Bison. Get it? Bison? Bison. Bison. That kind of made sense. I hope that made sense. But don't worry, I'll be coming up with some more jokes eventually. But yeah, anyways, guys, thank you guys for watching, and